Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, if you look at the denominator only, so this is your denominator. I'm going to add an amount to this. So I'm going to add 1 to this thing. So we will have 3. We will have n 3 to the power of n. If you add an amount to this, then this thing here will be bigger or equal to this thing here. So now looking at this, I'm going to add an extra amount to this. So I'm going to add n to this thing. So we're going to have 3. We're going to have n 3 to the power of n plus n. Don't forget n is from 1 to infinity. So here I'm not adding a negative number. I'm not adding negative 3. I'm always adding a positive number like 3. So I'm adding an amount to this denominator. Therefore, if you're adding something to this bubble, then this bubble here will be bigger or equal to this bubble here. So basically, this one will be bigger than this one. Therefore, we can say that this one will be bigger than this one here. So looking at the denominator, I can compare this to hang on, let me tidy this up. I can compare this to this. Hang on. So exactly the same on the numerator, and then for the denominator, n 3 n plus n. So we know that this thing here will be bigger or equal to this thing here. Well, bigger than this thing here. Well, if you make the denominator bigger, therefore the overall thing here will be smaller or equal to this thing here. Because if you look at, let's say 3 over 7, if you make the denominator bigger, which it is in our case here, this is bigger than this. If you make the denominator bigger, then looking at this, if you make the denominator bigger, then you can actually say that this will be smaller than this thing here, the whole thing. If you make the denominator bigger, then the overall thing will be smaller. So we know that this thing here will be smaller or equal to this thing here. Okay, so the trick is to compare this to this. So hang on. So looking at this, so we are trying to determine this, but then looking at the denominator, so we want to get create this denominator and then factor out the n, because if you look at this, n is in common, factor out the n, that will then give you this. So now notice that this thing here is exactly the same as this thing here. So when you first start out with this, try to get these two to be the same. So you can, well, if you somehow can get it to this plus n here, then you can factor it out like this. So that these two will cancel each other out. So the trick here is to turn this into this. So we know that this thing here would be less or equal to this thing here, and then factorize out the n. That will then give you this, and then these two will cancel out. These two will cancel out, giving you this. So really we are comparing this with something that we know about. We know about this. This we automatically know that it's going to diverge. We've seen it many times. Well, this thing here, something that diverges and is smaller or equal to the thing that we're trying to investigate. So this thing here, looking at this, hang on. So looking at this, the harmonic series is going to diverge, but then this thing here has to always be bigger or equal to this thing here. So it has no choice but to also diverge. It can't cross over like this and converge, because it has to always be bigger or equal to this thing here. It has to always be bigger than this thing here. So it has no choice but to diverge, because this thing here diverged. So therefore, the thing that we're trying to investigate will also diverge. It can't converge, because here you can see this will be less than this. Okay, so overall our series here will diverge. Okay.